Hello dear students. The contents you are able to see. Hello dear students.
Yes, ma'am.
Yesterday also I did the same, Jivita. I don't know why it has happened like that. Okay, we are in the Raspberry Pi. Okay, so we have studied the programming concepts and how the Raspberry Pi is going to be useful. Okay, and this and all studied. Okay, now today I told that I am going to start the smart city architect, that is a IOT architecture. Okay, this smart city architecture is to as I told that, 1 second. The smart city architecture is used for, it is a four-layered infrastructure, right? And the data flows from the devices of a street layer to the city network layer. So suppose why this smart city IoT architecture we are going to study is, we want to make our the metropolitan, especially the metropolitan cities as the smart cities. How you are going to make it as a smart cities means, see in almost all the metropolitan cities there will be too much traffic. Okay, there will be no parking places, right? And finding out the various hospitals and other required say marketplaces or shopping complexes, right? So you suppose I want to find out all these things. Okay, I can use the I can connect all the smart devices which are connected to the internet, right? And that information will be sent to our mobile phone. Say for example I want to park my four-wheeler. Okay, you know that especially in metropolitan cities there will be no place to park the vehicles, right? So that way we are going to find a difficulty, we are going to waste our time. So if you have the automation system where I can, so say particular area where I'm going to go for, I'm going to do the shopping, right? Where I can park my vehicle, right? So if the smart devices connected to IoT network, which is going to gather information when there is a the space to park a vehicle, right? So for that purpose, so that information has to go to the individuals in the city when they're going to use that particular app, right? So this is what the we want to make the cities to be very smart, right? And the people who are very busy in the cities, right? So they don't want to waste that unnecessary time in searching the place where to park the vehicle or where to find where is the hospital, a particular location of a given name of the hospital, right? And the shopping complexes nearby your area, like that, right? So if you are going to use an app, now we are already we are using, say suppose if you want to find out any location or any person nearby you, if you are going to give it in the Google, right, you will get the information, and so that you can have the work, get it done as early as possible, right? So that is the information, that is the data flows from the smart devices to the street layers to the city network layer, and they are going to connect it with the data center layer where the data is aggregated and normalized and virtualized. I told that smart devices, they are going to produce, they're called as the producers of the data. They contain lot of voluminous of data. So when they want to show the when they don't want to use all the data, they want to that data should be aggregated and should be filtered and condensed, right? So that is the reason why the where the data at the data center layer, the data is going to be condensed and filtered. What information actually required for a particular application, only that data is going to be kept it in the data center layer, right? No other information is going to be kept it, because it is a wastage of memory space, right? And searching process, or if you are going to store large volumes of data, searching process is also going to take place. It is going to take more time to search a particular data, right? That's why only, so different applications uses different kinds of data, right? That voluminous data which is generated by the smart objects in the IoT network, that data is going to be aggregated and it is going to be filtered to matches with that particular application for what purpose we are going to use, which consists of the application that provides services to the city. In smart cities, multiple services may use IoT solutions for many different purposes, right? And these services may use different IoT solutions with different protocols with a different application language. See here, just you see the how in a smart city, right? So how the things are get connected to the different layer. Okay, see there, first layer is a street layer, next layer is a city layer, next is a data center layer, and next will be the service layer, right? See now that we'll have the private clouds, partner clouds, and on-site clouds, right? Your delivery models will be the private clouds will be there, right? And partner clouds will be there for a city layer and for application layer and the service layer. So you will have the on-site clouds. Okay. So these see, they're different. Cisco, you are familiar with the Cisco company, which is very it plays a very important role, especially when it concerned with the networks, right? So new generation model implementation in the sites will be the service layer, and data center layer is going to give the unifying foundational platform with the depending on the use of case deployment. Okay. And IOE enables for a three-party sensors implementations and new smart services for cities and the citizens of the cities who are living in the cities. So here see the Cisco, the product and what are the services that Cisco is going to provide and who are the partners of this Cisco, right? So smart connected Wi-Fi transformational playback, okay, and uh, you have core routing switching, IoT industrial switching, routing gateways, and wireless APIs. And what are the services that Cisco is going to provide is Cisco is providing the consulting services and IOE for the smart cities, and it is going to plot the installation and deployment, and there will be a solution support. And Cisco partners will be urban services. It is going to provide, because why it is going to be give importance to urban services means like cities, so metropolitan cities or district places only for the district places and urban cities, because the networking, since it is works on the network, right? So there are, so you network is very good in the cities when compared with the remote places like villages. Sensors and other solution components, we are the partners, and customized design and the implementation, and managed with a service model and network operation and services at SLA support. These are the different Cisco things, and their products, services, and the partners will be the urban cities. So let me study one by one of the architecture, smart cities layered architecture. As I told, it contains street layer, city layer, and data center layer, and the services layer. So let me study what those layers are going to do. What is their basic functioning when they are going to become work as a street layer, city layer, data center layer, and the service layer. First, we'll take the street layer. Okay, street layer is composed of devices and sensors that collect data and take action based on the instructions from the overall solution, as well as the networking components needed to aggregate and collect the required data, right? As I told that the smart devices are going to produce a lot of information, and we are going to collect that data, and we are going to take up corrective action based on the instructions, or the based on the applications on the overall solution. Okay. And networking components needed to aggregate and collect the data. There are some networking tools which are available uh, to take that voluminous data and convert that into the required application. What is the application is required, what kind of data it is required, that is going to be aggregated and it is going to be distributed in the network. And a sensor is a data source. I told that the sensor which is connected in the IoT network, it is a source of producing of required and understand the physical world, and it produces voluminous data. And these sensor devices are able to detect and measure events in the physical world also, right? Say I told that when you are going to use an umbrella, right? When the one circuit is embedded in that umbrella, right? And that circuit is able to communicate with the physical world, and it is able to give the temperature variations of the variations in the what environment, right? And it can give the measurement of the temperature, whether it is sunny or cloudy, or it is a rainy. Okay, like that the sensor devices are able to detect and measure the physical world. Okay, ICT connectivity solutions rely on the sensors because they produce the data. That's why they depends on the sensors to collect the data from the world around them, and so that it can be analyzed and use it to operationalize use cases for cities. Okay, and come to the street layer. A variety of sensors used at the street layer, as I told, they are the producers of information. Variety of smart city use cases. Here is a short representative list. A magnetic sensor can detect a parking event of analyzing the changes in the surrounding magnetic field with a heavy metal object such as a car or a truck or comes too close to it on the top of it. As I told that the automation of parking system in any metropolitan cities. So there will be a magnetic sensor which is going to detect the parking event with the heavy metal object, like the vehicles, right? Like bus, car, okay, trucks, etc. Okay, and lighting controller can dim and brighten the light based on the combination on the time, based on the ambient conditions. And video cameras combined with video analytics can detect the vehicles, faces, and the traffic conditions for various traffic and security use cases. Okay, an air quality sensor can detect. So I told no smart cities, there are too many vehicles and too many traffic, they produce a carbon dioxide. Okay, so even you have the air the quality sensor which is going to detect and measure the gas and particulate the matter concentration to give a hyper localized perspective on pollution in a given area. So if we are going to set a threshold, what will be the, say, carbon dioxide is also there in nature, right? And what will be the concentration of carbon dioxide and what will be the concentration of the oxygen, those are going to be detected by air quality sensor, right? And device counter give an estimation of the number of devices in the area. Counter, say there will be a one counter which is going to count when as soon as the object moves, or the it gets motion of that particular object, right? So it is going to be counted as one object and one vehicle, and it is going to estimate. It's not approximately it will tell, right? Based on the whatever the conditions we have specified, what kind of device is moving in and around the in that particular area, which provides a rough idea of the number of vehicles moving or parked in a street or public parking areas. Okay, uh, pedestrian on a sidewalk, or even the birds in public parks or on public monuments for cities where bird control where bird control has become an issue in cities, because you know that. So even for flying of the aeroplanes also, okay, we have to see the flying of the birds. Okay, that is also very important. Next layer will be the city layer. So the at the city layer, which is above the street layer, network routers and switches must be deployed to match the size of the city data that needs to be transported. Say there are a variety of cities, district places, taluk places, and metropolitan cities, and capital cities, like, okay. So depending upon the size of the city, what we are going to is we are going to deploy the switches, the network routers on the street layer, in the city layer, so that the data is going to be transported very easily without any difficulty. This layer also aggregates all the data collected by sensors and end node network into a single transport network. Okay, the city layer may appear to be simple transport layer between the edge devices and the data center, or the net internet. Okay, they are going to give the edge devices so that it is going to be the data center or the internet. So see, however, one key consideration of this city layer is that it needs to transport multiple types of protocols, because you are running too many applications in the IoT network, right? So for multiple types of IoT applications, right? Some applications are delay and jitter sensitive, and some other applications require a deterministic approach to frame delivery. A missed packet may generate an alarm or result in an invalid status report. As a result, the city layer must build around resiliency to ensure that a packet coming from a sensor or gateway will always be forwarded successfully to the head-end station. Okay. Now see how the city layer is going to work. So above the street layer, okay, there is a city layer which is having the switches and gate ways, right? So okay, see there, aggregation switch 1 Gbps. Okay, edge port. See how the information is going to be blocked, alternative port for a video of VLN. Okay, and it will have the second generation and third generation waves. Okay, so in that way they are going to have the communication with each other. Okay, and street layer, see there how it works. It will have all the data is the collection of the data is going to be done at a data center layer, and from there the data is going to be distributed to the different routes, and from there it is going to the switches, right? So that is how the city layer and street layer are able to. So in this model, at least two paths exist from many aggregation switches to the data center layer. A common protocol is used to ensure this resiliency is the resilient Ethernet protocol. We call it as CREP, segment 100. You can see there how the second generation waves are passing from one switch to the other switch. Okay, so that is how your smart city model layer is going to work with the data at the center layer. A common protocol is used that is called as REP, which stands for Resilient Ethernet Protocol. So next is after the street layer, after city layer, you come across a data center layer. Okay, the ultimately data is collected from the sensor, is sent to the data center, where it can be processed and correlated. So processed and correlated are nothing but the data aggregation, data normalization, and data condensation is going to be done at this junction of the layer. That is a four-layered architecture. No, city smart city architecture. One is a street layer. Second one is the see there, street layer, city layer, data center layer, and the service layer. This is a four-layer architecture. Okay. So now this data center layer, based on this processing of data, meaningful information and trends can be derived, and information can be provided back. Okay. For example, you take an application in data center can provide a global view of the city traffic and help authorities to decide on the need for more or less common transport vehicle. At the same time, an automated response can be generated. Okay, then the cloud model is the chief means of delivering the storage, virtualization, adaptability, and the analytics know how that city governments requires for the technological mashup and synergy of the information embedded in a smart city. So this data center layer is also having the, we can call it as a city network. Simply it cannot keep up the real-time data needs by the smart cities. they are encumbered by their physical limitations, right? Okay, the cloud enables the data analytics to be taken to the server farm with a large and extensible processing capabilities. So this cloud model is a chief means of storing the delivering the storage, virtualization, and adaptability, and the analytics know how that city governments are required for different kinds of information that is required by the smart cities. Okay, just see here data center layer, that there will be a cloud and its services, how the data is going to be sending and receiving to the different applications in the smart city. See now, so intelligent medical center you have, right? And you have hospital government network optimization, right? And there is the traffic cameras, they are going to send the data to the cloud, and that data is going to be distributed to all the people in the city, right? And hospital optimization, smart grid, okay. And there is a BBMP, that is a municipal corporation, okay, which is going to control all the, and factory optimization, okay. And inflict flow optimization, home energy management, communication network optimization. See here there is a intelligent hospital which is connected to the articulants, and suppose ambulances if you want from the hospital, right? So which are the hospitals that ambulance is available, you just see that how the cloud provides a scalable, secure and reliable data processing engine which can handle the immense amount of data passing through it. This figure illustrates the vision of initializing the cloud in smart solutions for the smart cities. See the how the cloud and its services are going to be distributed to the different areas in the different applications in the different parts of the city. Okay, this is how your data center layer is going to access the information. See there hospital optimization, so it is going to give the intelligent hospital, and there are some ambulances are there, okay. Then we have the responsive stores and municipal corporations, which is going to whatever the updations they are going to make, that is going to be stored in the cloud. From the cloud, the citizens of that particular city is going to get the information regarding whatever they required from the municipal corporation, right? And this is how your data center layer is going to share the data which is stored in the cloud, okay. And it is going to be distributed to all the people, all the citizens of that particular city when it has got a smart city, and which is going to use with a 4-layered architecture, okay. And last layer where ultimately the it is going to be distributed to the end users, right? So the true value of the ICT connectivity comes from the services that measure the data can provide different users which are going to operating within a city. So overall are going to download a particular app to for different applications, right? They will get the information from the cloud where the data center, and you observe that how the data is going to be distributed in the network. So smart city applications can provide value to and visibility for a variety of user types, including city operators, citizens, and law and enforcement. The collected data should be visualized according to the specific needs of each consumer of that data, and the particular user experience requirements and the individual use cases. Okay, then the smart city security architecture. As I told that different whatever the street layer data it is produced, okay, that data is going to be pass on to the data layer, okay, that is a city layer. Okay, and from there it is that data is going to be stored in the data center layer, that is in the cloud. Okay, that data is going to be distributed in the network, okay, for different types of applications. So whatever the data it is moving in the network, right, we have to provide the security for that data. Until unless you are going to give that security of the data, any person can steal the information and they can misuse for different purposes, right? So for bad purposes maybe, okay, we'll think of that also. So that's why we have to provide the security for that smart city architecture. Okay, so whenever it is a serious concern for most of the smart cities and their citizens is data security, right? So vast quantities of sensitive information are being shared to all times in layered real-time architecture, and cities have the duty to protect their citizens' data from the unauthorized access or collection and the tampering of the data. So in general, citizens feel better about the data security when the city itself and not a private entity it owns a public or a city relevant data. So that is very important that every citizen should be protected. So no one should use the data whatever it is distributing in the network. It should not be misused by some person for bad things. Okay, so it is up to the city and the officials who run it to determine how to utilize this data. uh, a security architecture for smart cities must utilize security protocols to fortify each layer of the architecture and protect the city data. It is very every citizen the right is that they have to provide the security for the day security for the smart city, that is the security for the data which is there in the data center layer, right? And it should be utilized for it can be secured by using the security protocols in the layer of this architecture and protect our city. So the diagram which is going to specify the reference architecture with the security elements is highlighted, and security protocols should authenticate the various components and protect the data to transport throughout. Now, the smart city security architecture, you just go through the architecture. Okay, you yourself can understand that. Just go through. There is a data center layer, right? There is a internet service layer, okay, and at the um, after city layer you have the data center layer, right? See there how security is maintained in the data center layer, because from there only the data is going to be hacked, right? So there only we are going to create the protocols which provides the security for the data which is present in the data center layer. Just go through the diagram. And what are the key smart and connected cities references? So this is architecture for the smart city security architecture. Just you have to study very important. You have to concentrate on the data center layer. Okay, because from there only actual your data is going to be aggregated, and from there only the people are going to steal the information, right? You just study this architecture. I'll give 2 3 minutes time just to memorize the architecture of four layered architecture of the smart city, right? That is a street layer, city layer, data center layer, and the service layer. And you have to understand what is the functionality of these four layers. Okay, then we are going to get from each layer. Okay, you just go through the by scrolling the notes, right? You understand, and if you have any doubts you ask me. So from tomorrow I